Hi there. In this video, we are going to be going over fractional exponents, or more basically, exponents that are fractions, like this guy here and this guy here. For this, you're just really going to want to know what exponents are, which is repeated multiplication of a number, and this method of writing them. Maybe not with the numbers down here, because it's not going to help so much, but as a quick overview, a to the x, there are x8, so 1, 2, 3, all the way up to a. To actually use a number, a to the fifth, it would be 1a, 2a, 3a, dot, 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 means everything between a to 5. So the only thing in between here is 4. But say this were a to the 20, then this would be 1, 2, 3. The dots would represent everything between 3 and 20, so 4 to 19, and then the last one would be 20. You're also going to want to know this property of fractions, which I don't think I'm going to be making a video on, but I will if there are requests for it. But basically you can reorder things so that if a fraction is being multiplied by a number, you can make it so the numerator, the top number, is being multiplied by that number, and it's still just over the denominator, the bottom number. And of course you can reorder it just in general with the fraction first times the other number. As long as you got that, you will be fine here. So, we're going to start this with something hopefully everyone knows. Squaring, and then undoing squaring is square rooting. So, 2 squared equals 4, square root of 4 equals 2. And it works for any square. 3 squared equals 9, square root of 9 equals 3. Alright. Now, we're gonna keep going with squaring, and this is going to help illustrate how we get into the fractions here. So, I say so a lot. A squared is 2a's, a to the fourth is 4a's, because we're doubling. A to the 8 is 8a's. 3, 4, 5, 6, 7, 8. My a's are getting pretty good. So, we all know that when you square root this, we get just a. So, another way of writing that is a to the 1, because that's just 1a. So, 1a, and then another way of writing it is square root of a squared. A squared is actually an alternate way of writing the square root of a to the fourth. Hopefully you realize that, but if not, you can look at this as another way of writing this then. A squared times a squared, because this means 2a's times 2a's, and that's 4a's. Hopefully that's clear. 1, 2, 1, 2. So then we have one thing times the same thing, which is then this squared. So a squared squared. So that's why it turns into this. And it's similar down here. I'm not going to write out everything again, but rather it's the same here, where this is the square root of a to the 8. And then this would be the square root of a to the 16th. But I'm going to leave that as it is for now. I'll write it. Square root of a to the 16th. So as you can see, these keep getting cut in half, which is also that we've designed it that way, but that's how we're going to continue down the line. So now we want a to the 1/2 power, which, so square root of a to the fourth, square root of a squared. So the next line up should be just the square root of a. Now what does that equal? 4a's, 2a's, 1a, and then this is going to be something that multiplies by itself to get a, which by definition that is always the square root of it. So square root of a, I'll write it down here, square root of a times square root of a just equals a. So going down this line, 8 goes to 4 because it's cut in half, cut in half, cut in half, cut in half. So that's how this works, where it would keep going like this then. So then cutting it in half again makes it go to a to the 1/4. And that would be square root of a to the 1/2. Which is actually, you can even look at that as a to the 1/4. That's what I said already. My mistake. Getting a little bit frazzled, I guess. So now we'll work into more general terms so we can actually prove this is how it is. You might have you might realize that it'll work for any fraction, but I do want to do it in general terms to properly demonstrate. So a to the 1. So then if we make it be a to some other number, so that's a times a times a times a x times. If we do it again, so a to the x times a to the x, or no, not a to the times a to the x, we would do a to the x to the x. That would be a x squared. I'm going to get rid of these really quick. Keep everything in order. X squared. Because actually I don't think I've gone over that. So that is something that you should know. That some number to a power to another power, so in this case I'm using y, so this whole thing to y, what that equals is a xy. So if this ever happens, you just have to multiply the two exponents together and they become one new exponent. So here this was a to the x times x, so x times x is x squared. So now that's an exponent of an exponent. And it would just keep going like that, but we can stop there. So now we want the x roots. So x root of that goes back to a to the x. Then the x root of that goes back to a. So as you can see here, the exponent is being divided by x. So here it was just x divided by x there. So if we do the x root here, this becomes a to the 1 over x. Hopefully that was not terrible to follow. If the consensus is I was absolute garbage with that, I will remake this video and hopefully do it better. But that shows the basic case of just 1 over x. So now that we know that, I'm also going to delete this guy over here. And there's some smudges on the side. Oop. There we go. Now, next is this guy. So we know another way of writing fractions is a to the y times 1 over x. And then another way would be actually a 1 over x times y. So both of these are valid, and they would both make one of these basically, because in this case it's kind of like having parentheses around here. So here it would turn into a to the y to the x root, or the x root of a to the y, because 1 over x is on the outside of everything. Here it's like we have a to 1 over x times y, or to the y, not times y. That would be silly. So here, that turns into the x root of a. The whole thing, I didn't put parentheses up here, but it is pretty obviously outside, to the y power. So that's a pretty simple way of showing why this happens, at least, all using that property of fractions. Just remember that you can manipulate how it looks. Again, if this one was hard to follow, let me know, but hopefully this is a decent explanation to why fractional exponents work. And in case you were wondering, and you're interested in the last video, it does work with negatives as well. So say we have, excuse me, we're gonna use this one. So a to the negative y over x. This is a quick review. A to the negative x equals 1 over a to the x. So logically, this one would become 1 over a to the y over x, which then you can manipulate this further, 1 over the x root of a to the y. Not very pleasant to look at, but that is what it becomes. A way of demonstrating why this is. So it actually follows from the same logic as how we got this, where normally this would be, if this weren't, and it were just a fraction, we would have it, we would have, so if it were a to the y over x, that would mean we would have the x root of a y times. So that's x root of a times the x root of a dot 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 x root of a. And there are y of them, so I'll write the numbers, I guess. 1, 2, y. So there are y of these. If y were 5, this would be 1, 2, dot 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 5. So what that means then, for a negative power, instead of multiplying, we then divide, because then, so a squared, a minus 1, a minus 2. We keep subtracting, this is to the 1 power. That's 2 a's, and then going from there to there, we divide by a, so that's just a, divide by a. There should be a 0 here. So a to the 0 is then a to the a over a, and then a to the negative 1 is then 1 over a to the negative 2, 1 over a squared. So it goes the same way here, where we're starting at 0 and then dividing by the x root of a. That was probably just as, if not even more confusing than this. But again, let me know. I'll get better at this and hopefully offer some good help, which is just what I'm trying to do. If you have any questions, comment below. That'll help with further videos. Also, go ahead and ask about any other math questions you might have in general. I'd love to make just a video showing how to do a problem, even if I haven't gone over the methods, techniques, or whatnot to go through them. I'll make videos then for those techniques probably very soon, just to follow up. But yeah, that's it for this kind of long video. Next video will be more exponent stuff. Probably, yeah, it's going to be showing fractions and negative exponents with the power and, not the power, the product and quotient rule. So I will see you in the next video.